Hi mga katikno, I am Janice D. Tipon-Tipon and I am with my cameraman John Kakanog, and our content for today is all about carbon cycle. So let's start!
The carbon cycle is the biogeochemical cycle by which carbon is exchanged among the biosphere, pedosphere, geosphere, hydrosphere, and atmosphere of the Earth. Carbon is the main component of biological compounds as well as a major component of many minerals such as limestone. Along with the nitrogen cycle and the water cycle, the carbon cycle comprises a sequence of events that are key to make Earth capable of sustaining life. It describes the movement of carbon as it is recycled and reused throughout the biosphere, as well as long-term processes of carbon sequestration. The global carbon cycle is now usually divided into the following major reservoirs of carbon interconnected by pathways of exchange: the atmosphere, the terrestrial biosphere, ocean and geosphere. The ocean and land have continued to absorb about half of all carbon dioxide emissions into the atmosphere, even as anthropogenic emissions have risen dramatically in recent decades. It remains unclear if carbon absorption will continue at this rate. Epiphytes on electric wires. This kind of plant takes both CO2 and water from the atmosphere for living and growing. Carbon in the Earth's atmosphere exists in two main forms: carbon dioxide and methane. The terrestrial biosphere includes the organic carbon in all land-living organisms, both alive and dead, as well as carbon stored in soils. About 500 gigatons of carbon are stored above ground in plants and other living organisms. 5. While soil holds approximately 1,500 gigatons of carbon. 13. Most carbon in the terrestrial biosphere is organic carbon. 14. While about a third of soil carbon is stored in inorganic forms, such as calcium carbonate. The ocean can be conceptually divided into a surface layer within which water makes frequent, daily to annual, contact with the atmosphere, and a deep layer below the typical mixed layer depth of a few hundred meters or less, within which the time between consecutive contacts may be centuries. Carbon enters the ocean mainly through the dissolution of atmospheric carbon dioxide, a small fraction of which is converted into carbonate. It can also enter the ocean through rivers as dissolved organic carbon. Oceanic absorption of CO2 is one of the most important forms of carbon sequestering, limiting the human-caused rise of carbon dioxide in the atmosphere. However, this process is limited by a number of factors. CO2 absorption makes water more acidic, which affects ocean biosystems. The projected rate of increasing oceanic acidity could slow the biological precipitation of calcium carbonates, thus decreasing the ocean's capacity to absorb carbon dioxide. The geologic component of the carbon cycle operates slowly in comparison to the other parts of the global carbon cycle. It is one of the most important determinants of the amount of carbon in the atmosphere, and thus of global temperatures. Carbon can leave the geosphere in several ways. Carbon dioxide is released during the metamorphism of carbonate rocks when they are subducted into the Earth's mantle. This carbon dioxide can be released into the atmosphere and ocean through volcanoes and hotspots. 22. It can also be removed by humans through the direct extraction of kerogens in the form of fossil fuels. After extraction, fossil fuels are burned to release energy, thus emitting the carbon they store into the atmosphere. The carbonate-silicate geochemical cycle, also known as the inorganic carbon cycle, describes the long-term transformation of silicate rocks to carbonate rocks by weathering and sedimentation, and the transformation of carbonate rocks back into silicate rocks by metamorphism and volcanism. Most of the Earth's carbon is stored inertly in the Earth's lithosphere. 3. Much of the carbon stored in the Earth's mantle was stored there when the Earth formed. 22. Some of it was deposited in the form of organic carbon from the biosphere. 23. Of the carbon stored in the geosphere, about 80% is limestone and its derivatives, which form from the sedimentation of calcium carbonate stored in the shells of marine organisms. The remaining 20% is stored as kerogens formed through the sedimentation and burial of terrestrial organisms under high heat and pressure. Organic carbon stored in the geosphere can remain there for millions of years. The carbon cycle was discovered by Antoine Lavoisier and Joseph Priestley, and popularized by Humphrey Davy. Antoine Laurent Lavoisier was born to a wealthy family of the nobility in Paris on August 26, 1743. It is generally accepted that Lavoisier's great accomplishments in chemistry stem largely from his changing the science from a qualitative to a quantitative one. Lavoisier is most noted for his discovery of the role oxygen plays in combustion. He recognized and named oxygen, 1778, and hydrogen, 1783, and opposed the phlogiston theory. Joseph Priestley March 24, 1733 and died on February 6, 1804 was an 18th century English separatist theologian, natural philosopher, chemist, innovative grammarian, multi-subject educator, and liberal political theorist who published over 150 works. He has historically been credited with the discovery of oxygen, 5, having isolated it in its gaseous state, although Carl Wilhelm Scheele and Antoine Lavoisier also have strong claims to the discovery. Sir Humphrey Davy, 1st Baronet, December 17, 1778, May 29, 1829, was a Cornish chemist and inventor, who is best remembered today for isolating, using electricity, a series of elements for the first time, potassium and sodium in 1807 and calcium, strontium, barium, magnesium and boron the following year, as well as discovering the elemental nature of chlorine and iodine. He also studied the forces involved in these separations, inventing the new field of electrochemistry.